One important type of transformations that we can handle using the CDF method is the order statistic. Let me explain with an example. Suppose we have 5 random variables that are IID. They all have the same distribution and they are independent. Then they have got different values. So if I take one realization, I will get some values. Suppose these are the values that I get for some particular little omega. So once I run the underlying random experiment once, I get these values. Now I shall order them. This is the minimum. I shall call it x subscript round bracket 1. So for that little omega, I have this. Similarly, the next one is this. I will call that x round bracket 2 at little omega. In this way, I fill up all the other things. Since I can do this for every little omega, effectively I have defined a new set of random variables which are denoted by, these are called the order statistics based on my original random sample. Now I have written this with a little hyphen. That is not customary. I have done this just to highlight that this is plural of the word statistic. Any function based on your data is called a statistic. So this is a statistic, this is a statistic. Since I have many of them, so I am calling it order statistics. So people will actually not write this hyphen, but it is different from statistics as a subject. And it is easy to see that you have inequalities in this direction. Also notice that if there are ties, same value is repeated, then you really do not have any problem which one you call what, because the two values are the same, irrespective of, even if you switch them, you will basically have equality over here. The first order statistic is the minimum, and the nth order statistic, in this case n is 5, the sample size, that is the maximum. We will call this the second order statistic, third order statistic, etc. like that. Finding the distribution of order statistics based on the distribution of original x size, that is an interesting and important thing in statistics, and we use the CDF method for that. Let me explain by finding the distribution function and the density for maximum. So we are starting with this setup x1 to xn IID with density little f and CDF capital Fx. We want to find out the distribution of x bracket n, the nth order statistic, that is the maximum of all these. So it's a good idea to try to find out the CDF of this, because CDF is something that always exists. By definition, the CDF is probability that the maximum is less than or equal to x. But if the maximum is less than or equal to x, that means all the x size must be less than or equal to x. Now the x size are all independent, so this thing will factorize. Now this quantity is nothing but the CDF of xi. Now all the xi's have the same CDF capital F, hence this becomes fx, the entire thing, to the power little n, because all the terms are fx. So that is the CDF. So now we can try to find out the density of xn by just differentiating. I already know that if I differentiate this, I will get little f. So let's try to differentiate capital G. I'll be using chain rule. N, then fx to the power n minus 1. I have differentiated with respect to fx. Now I have to differentiate fx itself, and that will give me little fx. Now you must understand that when I am writing this prime symbol, I mean differentiate whenever possible, and if you cannot differentiate it, set it equal to 0. That is already built into the relationship between these two. Using a very similar argument, you can also work out the distribution of the minimum instead of the maximum, and we shall do this in the exercise. Exactly same setup as before, except that now you have to find out density of x1. Again, proceed like this, find CDF, then differentiate.